After a hypothesis has been thoroughly tested, it can form the basis for some deeper explanation of what's going on. That well-tested, general, comprehensive explanation is called a theory. In chemistry, the central theory is the atomic theory, which assumes that normal materials are made out of atoms, which can bond together to form molecules. In biology, you have the theory of evolution. In physics and in chemistry, both, you have the quantum theory. The ideas in a theory can be used to build a model. A model is an imitation of reality. A model can be an actual object like the ball and stick models of molecules you've probably seen before, or a model can be mathematical. In chemistry, one of the mathematical models that we use a lot is called molecular dynamics. It tries to make predictions about anything from reaction rates to biological activity of a molecule from the motions of very simple models of molecules. Now, sometimes models are built from theories, and sometimes they're built by directly fitting experimental data. An ab initio model, ab initio, is built around theoretical ideas. An empirical model is built by fitting experimental data. Now, sometimes you can have a model that contains elements of both of those things. They call those semi-empirical models. So, how can you judge whether or not you have a good model? A good theory or a model will make useful predictions. When a model predicts something incorrectly, it means that one of the assumptions that you've made in the model must be wrong, and that's a very useful thing to know. We can fix it then and try again. And this is the thing about models. They are continuously improved as new data becomes available. A good theory or model is as simple as possible, but not any simpler. That makes it easier to understand. Sometimes when you oversimplify, or if you start to confuse the model with actual reality, you're going to start to see paradoxes and bad predictions. You'll need to use a more sophisticated model, but perhaps one that isn't as intuitive. And we'll see this in a few weeks when we study the structures of molecules with a simple theory, Lewis theory, and more advanced theories, valence bond theory and molecular orbital theory. A good theory can connect things that maybe you hadn't realized were connected at all. And finally, a good theory is going to suggest new lines of work, new directions to move in, and new ways to think. We have some models, like we're going to see in a little bit, the Thomson plum pudding atom, that seemed to explain the facts that we had available at the time, but did not suggest ways to move forward, and they were eventually discarded in favor of models that did.